So we have a very interesting problem for you this week, but before I get into the problem, let me tell you about a new series that I started, and it's about advanced data structures and algorithms. So if you like this format of Whiteboard Thursdays, I think you'll love the new series, and it's designed to help you master advanced data structures and algorithms. And the way it works is that this week I will send you an advanced problem, and you will have a week to try it out yourself. And the week after, I will send you a high quality video explaining the solution. So if you're interested in more advanced problems, I have a link in the description below where you can subscribe. So let's move on to this week's problem.
So for this week's problem, you're given an array of integers. You have to transfer all zeros in that array to the end of the array. How would you do it in place without creating a new array?
So let's say we have an input array that is an array of integers, right? So let's say I have an input of 0, 1, 2, 0, 3, 0. And the output then should be an array that has all of the non-zero elements to the left and all of the zeros to the right, right?
Correct.
3 zeros to the right. Okay, so in this case, I think we would need to iterate through the input array, and we would need to swap the zeros so that at the end, the result would be that all of the zeros are swapped to the right. So if you don't mind, let me lay down the function, and we can think through it as I'm going through the function.
Yeah.
So let's say I have function let's call this shift, and it takes in the array, and the output would be the same array but the zero shifted to the right. Now let's say I'm iterating, so for I equals 0, I is less than array dot length I plus plus. So if I encounter 0, so let's say if array I equals 0, then what do? We first of all find the next non-zero integer, right? In the array. So let's say I encapsulate that function and I'll implement it later. Let's assume I have a function that finds the next non-zero integer. So let's say I have find, let's say I say j equals find nz, and I give it I just as a starting index, and then j comes back with, in this case it'll be index 1. Let's say j comes back with index 1. The next thing I want to do is I want to swap index 0 and index 1, right? And let's say I have a function like that. I can implement it later. So right now I'll just say swap I and j, right?
Yeah.
So the result of that would be, now I have 1 0 2 0 3 0. So the if statement is done and the for loop is done, right? And I think if we go through this, let's just iterate through all of the elements in this algorithm. Then the first iteration, it'll give me 1 0 2 0 3 0, and I is here. In the first iteration I was there, right? So in the second iteration, then I is here.
Yeah.
So then I will have 1, and then I is still 0, or array I is still 0. So then it'll swap these two. So I have 2 0 0 3 0. In the third iteration, I will have 1 2, and then in this case j should find me 3.
Yeah.
So I'll have 3, 0, 0, 0. Right? And then in the fourth iteration, then ideally I would want to stop right here or in the fourth iteration.
Yeah.
So let's see how we can do that. If you don't mind, I'll erase these iterations.
Yeah, sure.
Okay, we can probably leverage the find NZ function to stop right when the array is done, right? When we have shifted all of the elements to the right. So for that to happen, actually, I would need the j variable in the parent scope outside of the for loop. So let's say initially j is initially j is whatever. I don't need to declare it because I will find the value the first time over there. So let's implement the find NZ function. It takes in an index function, and it takes in an index, and it is looping through the array till it finds the next non-zero. So while array I is equal to 0, you keep looping, right? But at the same time, we don't want to go out of bounds. So we'll say while array I is equal to 0 and I is less than array.length. But if I have I is less than array.length, then it will stop at the end, right?
Yeah.
Let's say we don't want it to stop at the end. We want it to go a step further to indicate that we don't have any non-zero elements left, to search. So I'll say I is less than or equal to array.length. So while that's the case, keep incrementing I, right? And at the end, when the while loop is over, just return I. So in this case now, when I'm finding NZ, I will need a check after this that I'm only swapping I and j if j is within the bounds, right? So basically over here, I will have an if statement. If j is less than array.length. If that's the case, only then do you swap I and j.
So in this find NZ function, if you keep the condition of I less than or equal to array.length, then for the case when I gets equal to the length, it will check for array of I.
It will check array of I. You're right. So this should be over here, and this should be after this. I should flip the sequence over here. And to your point, then I would be checking that if j is over here, I'll be checking if j is less than array.length, because if it is equal to array.length, then we know that it just went out of bounds. And in the while loop over here, it'll check if I is less than array.length or less than or equal to, right? If it is not, only then, or if it is, only then will it check. Oh, I see what you're saying. So if it is equal to, then how will this pass?
Yeah.
Right. That's a great point. So let's say I have I is less than. Let's say I have I is less than array.length over there, and I'm doing I++, and let's say array I. So right now, let's say this condition was met, and then I did I++, and let's say it just equaled array.length over here. So this is going to fail, right? So let's swap these two first. So let's say I is less than array.length, and array I equals to 0. So now if it keeps on going, then eventually I will equal array.length over here, and it'll still satisfy our condition.
Yeah.
And then the next function is a swap function, which basically does this. Let's say I have two indices, I and j. It stores one of them, array I, and then it says array I equals array j, and then array j equals t. So that's how we'll swap both of them. And obviously these two functions will both have the array in the parent scope.
Yeah.
So they'll be part of the shift function.
And
I think this would give us the output there.
So, but still you're going through the entire array. Looping through entire array.
I'm looping through the entire array, that's right. And also for each one of the elements in the worst case scenario, I'm looping through the array again, so I have a for loop there, and for each one of the for loops I have a while loop.
Yeah.
So this is n squared time complexity. Now if I want a better time complexity, then I'll need to sacrifice space. So the other way to do this would be to iterate through this array and make a note in another array of all of the indices that are non-zero, right? So let's say I have the input array over here. As I'm iterating through it, I'm keeping a note to say that, okay, these are all of my non-zero indices. So index 1, 2, 0, 1, 2, 3, 4, 4 are non-zero indices. After going through it, I will make a new array, which is the same size as the input array, and I will copy all of the elements of these indices into the new array. So eventually in the new array I will get 1, 2, 3, and then for the remaining length of the array I will just say 0, 0, 0. So this will be a better time complexity, but it will be linear space complexity.
I see.
Yeah. The other thing I can do is actually eliminate one of these two arrays. So only instantiate one array, and as I'm going through it, if it's non-zero, I push it to that array, right? So eventually we'll end up with 1, 2, 3. And then at the end, when I'm done, I will say, oh, okay, whatever the difference is between the length of these two arrays, push that many zeros in. And that would yield the result in linear time complexity, but it'll be linear space complexity as well, just like in the previous scenario. I was using the swap method because my impression was that we have to do it in place. So guys, tip of the week is that if you're really looking to master data structures and algorithms, you just need to practice problems every week. I actually have a new series starting to help you do just that. So if you're interested, check out the description box below for more details. And this was it for this week, and I'll see you next Thursday.